Hello, welcome to NPTEL online certification course on Introduction to the Application of Artificial Intelligence to Robotics. Today we are going to see the various libraries and tools for ML implementation in Python. Okay. So, last two lectures we have seen learning and unsupervised learning. Okay. And today we are going to see what are essential libraries and tools which are being used for ML implementation in Python. Okay. So, the learning objective for the today's class is that to have an understanding of various libraries for ML implementation, then create and manipulate NumPy arrays, use SciPy for sparse matrix representation, build publication quality visualization with matplotlib, and then load, clean, filter and transform tabular data with say pandas data frames, and apply scikit-learn estimator API. Okay. So, I expect that by end of this lecture you will have very good idea about all these essential libraries and tools: Jupyter Notebook, NumPy, SciPy, matplotlib, pandas and scikit-learn. Okay. So, these are we are going to see. Okay. So, why Python for machine learning? You see, Python has become a very important for many data science applications. Okay. It achieves this position not only through raw computational speed, but through unique combination of properties, okay, that match the iterative exploratory nature of the machine learning framework. Okay. So, there are various advantages of Python as a tool for the machine learning application. Okay. It is a general programming language, and there are many specialized libraries available, okay, such as NumPy, SciPy, then pandas, scikit-learn, TensorFlow and PyTorch. Then there are interactive environments, say Jupyter Notebook, IPython is there, okay, enormous community is there, okay, and that helps many a times if you are facing some challenge. And then there are industrial standards, okay, which are adopted by many of the big giants in this industry. So, what are the essential libraries and tools? Okay. So, we have NumPy, which role is to have numerical arrays and math. Then typical use is for the data representation and linear algebra applications. Okay. SciPy is for the scientific algorithms. Okay. So, the typical use is that in the optimization, signal processing, okay, sparse matrices. Then matplotlib is for the visualization purpose, okay, where we can have plots, charts, okay, diagnostics and all. Then you have the pandas, the role is on data wrangling, and we can load a CSV or SQL file and data cleaning. Okay. Scikit-learn for the machine learning application, okay, where the typical use is in the training, evaluation pipelines. And IPython and Jupyter, they are basically the interactive shell or notebook, okay, where we can do the exploration and okay. So, the following are standard imports used throughout this notebook, okay. So, we can install the following libraries, okay. We can also use the Google Colab, okay, which is a cloud based tool, okay, for the Python programming. Alright. So, for numerical arrays we can have NumPy, scientific algorithm SciPy, then for visualization matplotlib, okay, tabular data structure and analysis pandas as PD. So, these are some of the standard format, okay, for these libraries, and interactive Python shell using IPython, and scikit-learn, okay, the main ML library. So, for that you have to import the S-learn. Okay. So, the Jupyter Notebook, one of the very popular browser based interactive computing environment, I hope all of you must have aware of, okay, and it is a great tool for exploratory data analysis and is widely used by data scientists. While Jupyter Notebook supports many programming languages, but here our interest is to use the Python, and it can easily incorporate code, text, images and all, okay, And as I said, Google Colab is a cloud hosted version that provides free GPU and TPU access. Okay, so how to interact in the Jupyter notebook? Alright, so these are some of the basics. Those who are using Python extensively, they must be aware of all these things. Okay, so you write code in the notebook in your browser, and the server sends code to the kernel basically. Okay, and the kernel executes, alright, using Python, and the results are sent back to display in the notebook. So this is the process. And you see, each notebook is connected to one kernel. Restarting the kernel naturally clears all the variable. Okay, and cell can be run in any order. The state is preserved, which enables rapid experimentation. Okay, and outputs we can have in the various forms such as plots, data frames, okay, print statements, and so on, and they are stored alongside code in the IPYNB JSON file. Okay, so let us look at the first essential library, that is NumPy. Okay, it's a foundation for numerical computing. Okay, you see, NumPy is one of the fundamental package for scientific computing, and what all functionality it has. See, you could have the multidimensional arrays here. Okay, you could have the high level mathematical functions, okay, such as linear algebra operations you can carry out. You can have the Fourier transform, and then it has pseudo number generator. Okay, and any data you are using will have to be converted into NumPy array before processing. Alright, and here there is one requirement, and that requirement is that all elements of the array must be of the same type. Okay, so here is just an example of NumPy code for the different function. Say here we import NumPy as NP, we create arrays. Okay, so this way a 2D array from nested list just can be created. Okay, so then we could have say a dot shape will be giving you the number of rows and number of columns. Okay, then a dot d type will be giving you the data type here. Okay, a dot ndim will be giving you basically the number of access. A dot size will be giving the total elements, and a dot strides actually gives you how many byte jumps is actually needed. Okay, say 24/8 means jump 24 bytes for the next row. Okay, and jump 8 bytes for the next column. Okay, so these are the output which you are going to see for that. Okay, then we can create a matrix. Alright, so here I want a 3 cross 4 matrix with all zeros elements, so I can create np dot zeros. Alright, I can create ones, say 2 cross 5 matrix of ones. Then if I want to have identity matrix, I can create that dot I4 means 4 cross 4 identity matrix. Okay, and then np dot full 3 comma 3 7 means it will be filled with constant 7, and empty creates 100 cross 4 matrix but does not fill it with anything. Okay, so basically it will contain the garbage numbers, okay, left over in your RAM until unless you are going to override them. Okay, then again there are other things also possible. Say np dot arrange here, it creates list starting at 0 and say ending with 10 here, 0 comma 10, and the increment step size is 0.5. Okay, so this can be done. Then you have, so dot line space, it generates exactly 500 numbers evenly spread across say 0 and 2 pi here. So this is how it is done. Then random default dot rng, basically it creates random number generator, and for example seed 42, okay, that ensures you get the same output every time. And dot standard normal, basically say it will be generating 100 cross 4 matrix of random decimal drawn from a normal distribution. Okay, and dot integer will create the 6 cross 4 matrix of random integer between 0 and 99. Okay, for this command. So let us take an example. Here we create a 6 by 4 matrix and perform indexing, slicing, and a filter operation. Okay, so this is the code actually. So first we set up a reproducible random number. Okay, and this is of seed 42 type, so that we get the same set of random number. We generate a 6 cross 4 matrix over here between number 0 to 100, and that is of size 6 cross 4. Say this is the matrix generated. Now we can carry out the basic slicing operation. Okay, so suppose I want first row only from here. Okay, so I can use this command. So I'll be getting the first row from here, this one. Then suppose I want all rows but only column 2. Okay, so basically the column 2 is going to be, this is my column 0, column 1, and this is my column 2. So this is what I am going to get, right? The same column. So this way I can get that column 2. And suppose I want to get a sub array. Okay, sub array in the sense that I want to get first, second and third rows of column 0 and 1. Okay, so here this is 1 to 4, means we have to go from 1 to 3, and similarly here this is from 0 to 2, so we have to go for 0 and 1 column, and this is for the rows. This is my 0th row, so 1, 2, 3 row, right, this one, and 0 and 1 column. So these are the 0 and 1 column, right. So I am going to get this slicing basically, right. So 43, 85, 29 and 73, 76. Likewise, if I want to perform the indexing, okay, so indexing performing means say jumping around say row 0, 2 and 5. Okay, so I can get row 0, row 2 and row 5 here like this. Okay, so this is the command basically. So I get row 0, this one, row 2, this one, and row 5, this one. This is the row 5, right. So this way I get that. And suppose I want indexing and a filter operation that I want to do with a Boolean mask. Okay, so suppose I have to get a number greater than 50, say from the 0th column, right. So here we could have say first number, here it is 8. So it is not greater than 50, so this will be false. The second will also be false, third will also be false. Then here 73, this is greater than 50, so this is going to be true. Similarly, 51 is greater than 50, so this is going to be true, and again 50 is going to be false. Okay, so this is there. And then we can ask, say, keep only the rows where mask is true. Okay, so in this case mask is true in 0, first, second, third and fourth row, right. So we can keep that. So this is 0, 1, 2, this is the third, and say this is the fourth one. So we get this as the answer. Alright, so this way we can perform the various operations. So this is possible, and this is what output we are going to get from the code directly. Okay, next let us look at SciPy scientific algorithm. Okay, you see, as I said, it's a fundamental library in the Python scientific ecosystem, which provides a collection of high performance functions for technical and mathematical computing. There are very key modules in it, say for the linear algebra, optimization, signal processing, mathematical functions and statistical distribution. The most critical component of SciPy for machine learning practitioner is the SciPy sparse module, okay, which is used to store 2D array containing mostly zeros to reduce memories. Okay, so here is an example. Use CSR, which is compressed sparse row, to convert. Okay, it stores only non-zero entities basically, so that one can significantly reduce the memory uses compared to the dense NumPy array. And it is very fast for the maths, okay, because we have lesser data to treat basically. Alright, so here is a code basically. Okay, so you import NumPy, then SciPy. Okay, so create 2D NumPy array with diagonal of 1s and zeros. Okay, so this we can have identity matrix. Okay, so that is there, and convert the NumPy array to say SciPy sparse matrix in CSR format. Okay, and only non-zero entities are stored over here. So this is my 4 by 4 NumPy array, right. So this is what SciPy sparse CSR matrix will be doing. So it will be essentially storing these diagonal elements. So 0, 0, 1, 1, 2, 2 and 3, 3. Okay. Then we use COO to build a matrix. Okay. And again here, while building this matrix, we need not specify the zeros. Okay. We can specify only those element location and the numbers. So to build a matrix, need to write down three things, that is the row, column and the number, right? And the syntax is, say, the data row and the column basically. Okay. And it is incredibly fast and easy to build and add new data. Alright, so that is there. And so again here import NumPy, SciPy, then say you have this array. Alright, so we could have the row array, we could define like this. Alright, and then create a sparse matrix. So it is basically like this. Say for 0 0 we have 1 1 1 for 1, 2 2 for 1 and for 3 3 1. So if I have to create that matrix, okay, so just by giving these coordinate and the values, I can create the matrix. Okay. So then next important tool is matplotlib. Okay, it is a primary scientific plotting library in Python actually. Okay, so we can do a lot of plotting activities. We can have the line chart, we can have the histogram, we can have the scatter plot and so on. Okay, and visualizing your data and different aspect of your analysis can give you important insight about the data, right. So every matplot is composed of, you have the figure, okay, then you have the axis and you have, say, artist lines, patches, text, tick marks and so on. So here is a basic summary of the functions and output basically. So here dot plot means basically it will create line chart or plot individual data points, say sine waves. Then dot scatter is will create a scatter plot to visualize data sample and cluster assignment. Dot subplots will be generate the figure with a grid of subplots, okay, useful for different model algorithm side by side. Okay, so it will be basically creating something like this. Okay, so in one plots you can have the 4 subplots, and then you can label the x and y axis, basically add descriptive label to the horizontal and vertical axis, and here set the axis limit, basically x limit and dot y limit. Okay, so basically to focus on a specific range of data. Then dot legend we can use to give the legend, okay, to distinguish between different classes, say training versus test data and so on. Then dot show to render the figure on the screen when we want to see the figure. Okay, so you have to render the figure on the screen. Then dot text, add text annotation directly once the plot at a specific coordinate is there. Dot semi-log, okay, plot data with a logarithmic scale on the y-axis. Okay, if your data is having very wide range, then we can do that. Dot hist is basically for the histogram, all right, and dot color bar actually adds color bar to the heat map or score visualization, okay, to indicate the magnitudes. So here is an example basically. Okay, so we can have a matplotlib, import NumPy, then generate a sequence of numbers from, say, -10 to 10 with 100 steps in between. Okay, so dot line space we can do that, -10 to 10 with 100 space, and then I can use this x, okay, to do the plotting, basically sin x. Okay, so the plot function makes a line chart of the array against the marker, and then we can give some symbol to the marker. All right, so this way we can do the plotting. Okay. Okay. Then next let us see the scatter plot with a class coloring actually. Okay. So again here we can have as learn dataset import make underscore classification, and then you can have the matplotlib. Okay, x class, y class. Okay, so suppose we are taking 200 samples and say 2 features are there, feature 0 and feature 1. Okay, and so we can have the scatter plot. All right, and here we can have the C map with blue, white and red. Okay, we can have the edge color as black, and X label is feature 1 here. Okay, then Y label is feature 2. So this way I can give title 2 class data set. So you get title over here. Okay, and we can label the class. Okay, so here is this way we can have the classification data. alright. So, that can be plotted. Okay. Next, let us see another essential tools for machine learning in Python, that is pandas. Okay. And we use pandas for the data wrangling and exploratory analysis. Alright. So, you see it is built around a data structure called data frame, okay, that is modeled after the R data frame. Okay. So, to simply put, the pandas data frame is a table basically similar to an Excel spreadsheet, alright. And the pandas data frame allows each column to have its own type. Okay, so you can have integer, you can have floats, strings, okay, date and time, and categorical things could be there. Then pandas can use multiple file formats and databases. Okay, so you could have the SQL format, Excel format, CSV format, that is comma separated values. Okay, all these could be there, and this makes pandas the standard tool for the data ingestion, cleaning and exploratory analysis before feeding data to scikit-learn. Okay. So, if we compare how does the NumPy and pandas differ, okay. So, you see the data type, in case of NumPy you need to have this all elements of the same type, okay, whereas in case of pandas it allows each column to have different types actually, okay. So, string, integer, float and so on. So, that is the basic difference. And if you look at the workflow, NumPy is used for the mathematical modeling and training phases, whereas pandas is used for the data ingestion, cleaning and wrangling purpose. Here is a code example, okay. Create a simple data set of a pupil with name, location and age, okay. So, here we can write say name, all names are here, okay, all locations are here and all ages are here. So, here basically you get name, location and age. So, you can see that each column has got the same data type, but different columns have got the different data type. Okay. So, suppose we want to select all the rows that have age number greater than 30. Okay. So, age greater than 30 we have got only these two rows, right. So, this way we can pick up that. Similarly, so we ask that return the first two rows, okay. So, we can get these as the first two rows, okay. Then return the last two rows. So, dot head is used for the first two rows, whereas dot tail is used for the last two rows, okay. So, this way we can extract data from the main data. The code examples could be various functions, say display data underscore pandas, it will be returning data table. Then we can have dot head basically return first n rows and dot tail and last n rows will be coming. Dot d type will be returning the data type of each column. Then dot info will return concise summary. Then call will select a single column, okay. Basically 1D labeled array will be coming, and here this command is used for selecting the multiple columns, okay. And here this iloc n comma m is basically used for the position based indexing, okay. So, next let us learn about scikit-learn, which is the machine learning library. Okay, so you see the scikit-learn is an open source Python library that serves as the industry standard and most prominent tool for the machine learning. There are core characteristic. Beautiful thing is that it is open source, okay, and this library is built on top of NumPy and SciPy. It's efficient, okay, and it's uniformly is perhaps the greatest engineering virtue. Replacing one algorithm with another requires just changing exactly one line of code. A defining feature of scikit-learn is that all machine learning models are implemented in their own class, okay, which is known as the estimator classes. An estimator class contains the specific algorithm to be used and store the model information that the algorithm extract from the training data, and the source categorize these estimator class based on the function in the machine learning workflow, okay. So, we could have the supervised learning estimator, unsupervised learning estimator, pre-processing estimator and the meta estimator, Okay. So here are various estimator APIs. Okay. So dot fit x, capital X we are using for the input and small y we are using for the output. Okay. So the purpose is to train model on data, return self. Then dot predict x underscore new, this generates predictions, returns array of shape, and then you have dot predict underscore proba, and this is basically for class of probabilities. Okay, returns n comma k array. Then this one is used for the default evaluation matrix, it returns a float. Dot transform pre-processing produces new representation, returns transformed x, and dot fit underscore transform xy, fit then transform in one step and returns the transformed x. So here is the code example with iris classification, which we have seen when I introduced this machine learning to you. Okay, so here these are the scikit-learn API script. Say model selection, pre-processing, neighbors, and data set. Okay. So model selection, train, test and split data basically, and then you have dot pre-processing, standard scalar, basically it is a math tool that performs z-score standardization. So that is there. Then we have the k neighbor classifier. Okay, we have learned about this in the previous lectures. And then we have built-in dataset containing measurements of iris flowers basically, right. So this way we could load iris, okay, and we split the data in training and testing data set. Okay. So here basically when we are loading the parameters which are there, and we have 4 inputs are sepal length, sepal width, the petal length and petal width, and outputs are the 3, that is the type of flower it is. Okay, that is Aries setosa, Aries versicolor and Aries virginica. So these are there. So here basically we can use the transform API for cleaning up the data, then fit API for to train the brain, predict API to make the guess in the real world, and then the score API. Okay. So here we are cleaning that training and testing data. Then we are using the k neighbor classifier over here. Okay. So here we are fitting the data, right, and then we are predicting the API. So these are the 4 inputs for the new flower, say. Okay, and these 4 inputs corresponds to these values basically, that is the sepal length, sepal width, petal length and the petal width. Okay, so these 4 inputs are there, and then again we clean the new data and then we predict. Okay. So in the prediction basically we are giving the score value and the accuracy value. Okay. So this way we can predict the which category it belongs to. As we have seen there are 3 categories, and here we get the model accuracy. Okay. So to summarize, you see the Python dominates ML due to ecosystem depth and interactive tooling, and NumPy n-dimensional array is the universal data container basically. All scikit-learn models consume NumPy array. Then we have seen SciPy extends NumPy basically, okay, which is used for the scientific computing. For the data visualization we have matplotlib, okay, and pandas for bridges array data file to scikit-learn, load, clean, encode and all. And then scikit-learn uniform API means swapping model require just changing exactly one line. So very useful tool for the machine learning. Alright, so these are the references which you can see: Introduction to Machine Learning with Python by Muller, and Introduction to Machine Learning by Ethem, and scikit-learn website. Okay, thank you. See you in the next class.